Hello students, I, Mrs. Madhavi Mhatre, welcome you all in the next lecture of Mathematics 1. I hope all of you are doing well at home. We are studying chapter number 4, Ratio and Proportion. In this chapter, up till now, we have completed the concept of ratio, then we have seen properties of ratio, then we saw operations on equal ratios, all the 5 operations we saw, and then the application of those equal ratios. Then we saw theorem on equal ratios. And in the previous lecture, I explained you the concept of continued proportion and K method. Also, we have discussed all the solved examples from the textbook. I told you again and again that solved examples are equally important. They may appear in exams, so you have to study them. Don't ignore them. Okay, now let's go towards the last practice set of this particular chapter. Because before that, we will revise what is continued proportion and what is K method. Okay, so here continued proportion is applicable of n number of ratios. Here, if we think about two ratios, A upon B is equal to B upon C, then we can say that A, B, C are in continued proportion. Okay, here you will observe that denominator of the first ratio and numerator of the second ratio, they are same. See, this denominator is continued further as the numerator of second ratio. Now further we can have A upon B is equal to B upon C is equal to C upon D. So this continued proportion is valid for n number of ratios. Now here, since we have three numbers, now we are thinking about three numbers. So in case of these three numbers, this B is called as mean proportional or geometric mean of A and C. Also, if we cross multiply, we get B square is equal to AC, or AC is equal to B square. So these two statements, A upon B is equal to B upon C, or AC is equal to B square, they have same meaning. It means that A, B, C are in continued proportion. Okay, so these two statements are equivalent statements. And as I said, B is called as mean proportional of A and C. And then we can say that mean proportional square or geometric mean square is multiplication or product of extremes. Okay. So when ABC are in continued proportion, B is known as geometric mean of A and C, or it is also called as mean proportional of A and C. Then we saw the solved examples based on that, and afterwards we moved towards the K method. So here K method means what? The given ratios we are going to consider as K. So this K method is used to solve the examples based on the equal ratios or equal proportions, and because of K method the things becomes very easy. So in this method we are considering or assuming the given equal ratios as equal to K. Okay, and this is a simple method. That means the examples become simple because when we assume that the equal ratios are equal to K. Okay. Now, after that we saw solved examples we have discussed. Then what to be noted is last solved examples 4 and 5. See this solved example numbers, I am sorry, 3 and 4, which are just above the practice set 4.5. They are under reduced syllabus. So take a note of this. Okay. All of you, please take a note of this. Now let's go ahead towards the last exercise. That is practice set 4.5. Now let us start. This exercise is based on continued proportion and K method. So first one here. Which number should be subtracted from 12, 16 and 21 so that resultant numbers are in continued proportion? Okay, so here we are provided with three numbers 12, 16 and 21. But these three numbers are not in continued proportion. You can observe here 12 into 21 is not equal to 16 square. So here they have asked us that which number we should subtract from each of these so that the resultant numbers will be in continued proportion. So always whatever is unknown, that we are going to take as x or we are going to take as k. As I have said, you can take any alphabet, but generally we take x. So always start with the statement from the question. So in place of which number, what you will write, let x should be subtracted from 12, 16 and 21 so that the resultant numbers are in continued proportion. Always take help of question to write down the first statement in the answer. Okay, so let x be subtracted from 12, 16 and 21 such that resultant numbers are in continued proportion. See, only this which number you have to replace by let x. Okay. Now after subtracting, the new numbers will be 12 minus x, 16 minus x and 21 minus x. Okay, so these three numbers are in continued proportion. Okay, so 12 minus x, 16 minus x and 21 minus x are in continued proportion. Now when they are in continued proportion, either we can write 12 minus x upon 16 minus x is equal to 16 minus x upon 21 minus x, or we can write down the square of the middle number, which is called as mean proportional, is equal to product of remaining two. Okay, so any way you can write. Either you can write down in the numerator denominator form, or you can write down like this, as you know that both the statements are equivalent. So here I am writing mean proportional square. That means the middle number, it's square. Write it in bracket. Don't forget to write in bracket. Otherwise the meaning changes. So 16 minus x the whole square is equal to 12 minus x into 21 minus x. Now this bracket you will expand using the formula a minus b the whole square, that is a square minus 2ab plus b square. And here you will multiply each term by each term, or you can use the expansion, that is x plus a and x plus b. That means here we will, in the beginning we will multiply 12 and 21, then we will add these two numbers and just beside that we will write down minus x, that means the negative thing, and finally minus x into minus x we will write x square. Okay, so see here 16 square is 256 a square. Then minus 2ab means minus 2 into 16, that is 32, and 32 into x is 32x. So minus 32x, and then b square. So x square means plus x square is written. Okay, so this expansion formula we used for this. And here 12 into 21, 252. Then add 12 and 21. So 12 plus 21, 33. And this minus sign. So minus 33x. And minus x into minus x is plus x square. Okay. Now what we can observe is this plus x square is on both the sides. So we can cancel it from both the sides like this. Okay. It will get cancelled. Now we have to equate the like terms. So this 32x we will shift to right hand side either, or this minus 33x you can shift to left hand side. Anyhow you can do. That means like terms with x and x we will write on one side, and the numbers constants we will write on the other side. So here this minus 33 you can shift here. So you will get 33x minus 32x in LHS, and this 256 you can shift here. So 252 minus 256. Anyhow you can do. Okay. So here the answer is 4 is equal to minus x, and therefore x is equal to minus 4. So we got the unknown number which we have considered in the between. In the beginning only we have considered this x and we got that as x. So we can say that here that minus 4 must be subtracted from 12, 16 and 21 so that the resultant numbers are in continued proportion. So write down the final answer as statement that therefore if minus 4 is subtracted from 12, 16 and 21, the resultant numbers are in continued proportion. Okay. I hope you must have understood this and you have copied it down. If you are lagging behind, then you can pause the video, you can complete it and then you can go further. Now let's move towards the second question. If 28 minus x is the mean proportional of 23 minus x and 19 minus x, then find the value of x. Now see here, in sequence you don't see like this. Don't think that these three numbers are in sequence. This is A, this is B and this is C. No, it is wrong. See, this is A and this is C and this is B. This is mean proportional. Okay. So try to understand. This is A, this is C and this is B, the middle number. So B square is equal to AC. That we know. That means 28 minus x the whole square is equal to multiplication of these two numbers. You have to be very careful here. Okay. So 28 minus x is the mean proportional of 23 minus x and 19 minus x. That is the statement which is from the question. Now let's start solving it. So we know that mean proportional square is equal to multiplication of extremes. Okay. So we will write this 28 minus x the whole square is equal to 23 minus x into 19 minus x. Let's expand it. 28 square is 784 minus 56x plus x square is equal to 437. Multiplication of these two is 437. Then minus 42x. 19 plus 23 is 42 and x as we have done in previous lesson. Previous sum. And minus x into minus x is x square. Again, you can cancel this plus x square and plus x square from both the sides and then you will get the answer like this. Now next step is to equate the coefficients or equate the like terms. So here we will take x and x together on one side and the constants on one side. Okay, so 784 minus 437 is equal to 56x minus 42x. See, this minus 56 has become plus and plus 437 has become minus. So when you subtract, you will get 347 is equal to 14x and therefore x is equal to 347 divided by 14. Okay, so this is value of x which we can get here. Okay, actually here if you observe these numbers, if you think, then here you have 19, here you have 23 and here you have 28. Actually this number should come in the middle. This should be the mean proportional of these two. Okay. But in textbook the question is like that only. That is why I have solved with like this only. If we see, you can see very clearly that 19, then 23 and then 28. That means this term should come in the middle. This should be the mean proportional. But in textbook the sum is given like this only. Okay. So I have solved it by using the same numbers. I have not made any change. Okay. So take a note of this. Now let's go towards question number 3. Three numbers are in continued proportion whose mean proportional is 12 and the sum of remaining two numbers is 26. Then find these numbers. Okay. So here we are provided with the mean proportional. That means the middle number, that is 12. And the extreme numbers, remaining two numbers are not provided. Instead, the condition is given, that is the sum of these two numbers is 26. That means if one number we take as x, the other number has to be 26 minus x because their sum is 26. Okay. So the remaining two numbers we will take as x and 20x6 minus x, and then we will use the property mean proportional square is equal to multiplication of remaining two numbers. Okay. So let's start. Let A, B, C be the three numbers in continued proportion. That means we are taking these three numbers as A, B and C. Then from the given information, we can write down that B is equal to 12. See, the mean proportional means B is equal to 12. Also, we know that B squared is equal to AC. When the three numbers are in continued proportion, we know that B squared is equal to AC. So, B is 12 and the sum of remaining 2 is 26, and then we have to find these numbers. Okay. So, we will take B as 12 and A plus C as 26, and therefore we can write down C is equal to 26 minus A. See, the mean proportional means B is 12 and sum of remaining 2 means A plus C is 26. Or as I have said, you can take one number as X and other you can take as 26 minus x. That also will do. Here I have taken A and 26 minus A because generally we are taking A, B and C. Mean proportional definition when we saw it as B square minus AC. So to avoid confusion, I have taken A, B and C. So always write down what is given to you from the question. Okay. Now see, these values, that means B is equal to 12, we will put here in left hand side of equation 1, and value of C, that is 26 minus A, that also we will put here. Okay. So when we substitute this here, then we will get the equation like this. So write down, substituting B is equal to 12 and C is equal to 26 minus A in equation 1. So see, B square means 12 square is equal to A is written as it is, and in place of C, 26 minus A is written. Okay. Now let's open this bracket. At the same time, let's square this. So we know that 12 square is 144, and here 26 into A is 26A, and A into minus A is minus A square. Now let's shift these two terms on left hand side and write it properly in the descending order of powers. Just recall the polynomial chapter. Always while writing in standard form, we write it in the descending order of the powers. So we will write it properly like this. A square, see, minus A square became plus A square, plus 26A became minus 26A, and this plus 144 as it is. And then don't forget to write down equal to 0 because it's an equation. So we also have to write equation. Now only consider these parts. See, in polynomials we have studied factorization. We have studied the method to factorize the quadratic polynomial by splitting the middle term. So recall that. So here the coefficient of the first term is 1 and here it is 144. So 1 into 144 is 144 and plus 144. So we will consider two numbers whose multiplication is 144 and addition is minus 26. So that means both the numbers are negative. Okay, so here you are going to factorize 144. Okay, recall that polynomial. See, 144 we are going to split. And as I have said, since middle term is negative, both the numbers are going to be negative. So 144 comes in the table of 18. You know that 18 8s are 144. Okay. So you write down that here. The one number is 18 and other number is 8. So in this way, we are going to get those two numbers. I hope after seeing this, you must have recalled that method. So this we can split. Okay, see. So a square minus 18a minus 8a plus 144 is equal to 0. See, this minus 26 is split as minus 18 and minus 8. Minus 18 plus minus 8 is minus 26. Then you know that the next step is to take out common. We have to group. After grouping, we have to take out the things common. So here you will observe that a is common, and here we will take out minus 8 as common because 144 one factor it is 8. So we will take as minus 8 common here. Okay, so let's move ahead by taking out common here. So please complete this. If not completed, pause the video and then go further. If you want, you can write this by the side to understand that how this step has come. Why we wrote this minus 26a as minus 18a and minus 8a. Okay. So previous knowledge also is useful. It is applicable. So don't forget it. So let's go ahead. Let's take out common here now. Okay, so let's take out common here now. So from the first pair we have taken out a as common, then inside the bracket we have a minus 18, and from the second group we have taken out minus 8 as common, and inside the bracket we have a minus 18. You know that always these two brackets are same, we are getting them same, and again we are taking them out common, and we get two brackets, two factors of that polynomial as a minus 18 and a minus 8 is equal to 0. Now see, this is one number and this is another number, and product of these two numbers is 0. That means if we take this as a and if we take this as b, so a b is equal to 0. So we can say that either a is 0 or b is 0. Similarly here we will write that a minus 18 is 0 or a minus 8 is 0. Now this minus 18 we will shift to right hand side. So here we will get a is equal to 18, and if we shift minus 8 this side, then we will get a is equal to 8. So in this way we got two possible values of a, that is either a is 18 or a is 8. And therefore we will get two possible values of c, as you know that c is 26 minus a. Just see the beginning part there. So if we consider value of a as 18, then 26 minus 18, that is 8. Value of c will be 8. And if we consider the value of a as 8, then the value of c is 26 minus 8, that is 18. Okay. So the numbers, see the middle number is already known to us, that is 12. So the numbers are 18, 12 and 8, or 8, 12 and 18. Okay. So this way we are getting two answers here, because we got two different factors and both the numbers are valid, both are positive. Here in this case, if one is negative and one is positive, then we would have discarded the negative number, because when the numbers are in sequence, then they will be positive only. The negative number will not come in between. But here both the numbers you got positive, so we have to consider both the numbers, and therefore we have to write down both the possibilities. Okay. I hope you must have understood this. Now let's go ahead. Question number 4 here. If a plus b plus c in one bracket multiplied by a minus b plus c is equal to a square plus b square plus c square, show that a, b, c are in continued proportion. See here, we have to prove here that they are in continued proportion. Means we have to prove that b square is equal to ac. If we prove b square is equal to ac, then the statement means that a, b, c are in continued proportion. Because when we have studied continued proportion, I told you that a, b, c are in continued proportion, or B is mean proportional of AC, or B square is equal to AC, or B is geometric mean of AC. All these are equivalent statements. Their meaning is same. They convey the same meaning. So here when we want to prove ABC are in continued proportion, we have to prove that B square is equal to AC. Okay. But see, this is what we want to prove. So don't start with this. always start with what is given to us. Okay, so this equation is given to us. Write down that equation in the beginning. This is given part. So always start with that. Okay, so we will write down the equation as it is from the question. A plus B plus C into A minus B plus C is equal to A square plus B square plus C square. This is given. Now let's open these brackets or let's expand left hand side. So we are going to multiply each term by each term. So all of you start writing. A into A is A square. Then A into minus B is minus AB. Then A into C is AC. Then B into A is AB. B into minus B is minus B square. And B into C is plus BC. Similarly, C into A is AC. C into minus B is minus BC. And C into C is C square. Okay, so check now whether you have written it correctly. Once again, see A into A square. A into minus B, minus AB. A into C is AC. Now take second term, that is B. B into A is AB. Don't write BA, always follow the alphabetical order. So AB you write. Then B into minus B is minus B square. And plus B into plus C is plus BC. Then C into A is AC plus AC. Then C into minus B is minus BC. And plus C into plus C is plus C square. And copy down right hand side as it is, A square plus B square plus C square. Okay, now let us go for cancellations. Okay, so be very careful with the cancellations. Now see here, we have plus A square in LHS and plus A square in RHS. So you can cut it. Similarly, you can cut C square and C square. But please take a note that you cannot cancel B square and B square because their signs are different. Observe the signs. See, here you have minus sign in LHS and here you have plus sign. So B square and B square will not get cancelled. Don't hurry, don't cancel them. Now let's see the left hand side. Here also some terms can be cancelled because they are like terms with opposite signs. Like see, minus AB and plus AB got cancelled. Plus BC and minus BC got cancelled. Okay. But see, this plus AC and plus AC, they are having same sign. So we cannot cancel them. Now, let's write down the remaining terms. Let's add them. So, what we will do is this minus b square we will shift here. So, it will become plus b square. And here AC plus AC we will get 2AC. And here b square plus b square we will get 2b square. Again, these 2 on both the sides we can cut. We can divide both the sides by 2 and it will get cut and we will get b square is equal to AC. Okay, now as I have said, b square is equal to AC means A, B, C are in continued proportion. Okay, so we have proved this, that A, B, C are in continued proportion. But after reading, you should understand that if we want to prove A, B, C, D are in continued proportion, means we need to prove that B square is equal to AC. This must be understood by you. That is why in the previous lecture, I gave you all the statements which convey us the same meaning, which gives the same meaning, and we can make use of that to solve our sum. Okay. Now here the sums which were based on continued proportion, those sums I have solved. Now the sums based on K method are remaining. Those sums we will start in next lecture. Okay. So all of you please be practice all the sums. Also try to solve the similar sums from problem set because I am not going to solve similar sums from problem set. I am going to solve only the sums which are different here. Okay, because we have came to an end of this chapter, only few sums are remaining. So in the next lecture I will discuss the remaining part of practice set 4.5 5 and then we will start with problem set 4. Okay. So students, today I am stopping here. We will meet in next lecture. Till that, you stay home, stay safe, take care of yourself. Thank you students.